Welcome back to the Defense Tech Podcast. Today we have another Tech Talks episode where we take a deep dive into some of the technologies that are shaping the defense industry today. This week I have the pleasure of talking with John Cowles from Analog Devices. John is the Senior Director of Technology at Analog. He has over 20 years of experience in the semiconductor industry in various specialties such as defense electronics, microwave radios, as well as power detectors, phase shifters, and radar-focused products. He earned his PhD at the University of Michigan in electrical and electronics engineering. In this episode, John shares his experience on advanced packaging technologies, SOCs, and the U.S. effort of re-onshoring microelectronics and advanced packaging production capabilities. Without further ado, I hope you enjoy this episode with John Cowles. Hi, John. Welcome to the podcast. So glad to have you on this week, and I'm excited to hear more about you and Analog Devices. So if you wouldn't mind just starting by telling us a little bit about yourself and your experience in the tech industry.
Hi, Sydney. Yes, thank you for inviting me, and I'm really excited to talk about the state of the semiconductor industry and how ADI participates and helps the DoD. So, yeah, my name is John Cowles. I'm a Senior Director of Technology at Analog Devices. I was actually born and raised overseas in Brazil, but then I moved to the U.S., completed high school, and then I did my bachelor's at University of Pennsylvania in Philadelphia, and then followed it up with a master's PhD at University of Michigan with a focus on semiconductors. So that's been a part of my life for a long time.
Nice. Go Blue, by the way.
Go Blue.
I was born and raised in Michigan, so big fan.
Right. Yeah.
Awesome. Well, I'd love to hear more about your experience working on tech for the DoD specifically and how you came to work for Analog.
Yeah, when I completed my doctorate, it was actually during a downturn, not a lot of opportunities in the commercial space. So I was really lucky to get my first opportunity at TRW in Redondo Beach, California. It's a fantastic location, great people I worked with and learned from. And I spent almost 5 years, and it was, of course, in the defense industry. And I didn't realize actually how interesting advanced technologies defense was working on that I only realized after I left and saw how all of that was rediscovered in the commercial space later. I joined ADI about 5 years later and started my career as an IC designer working for one of Analog Devices' first fellows, Barry Gilbert, who's a world-renowned rock star of circuit design. Kind of interesting, when you live with a rock star.
Yeah, absolutely. Awesome. So what kind of projects are you involved in now?
Yeah, and as part of my career at ADI, I started out as an IC designer. I got more involved in system level definition of products, but as ADI moved from being a component supplier, a product developer of individual pieces, we moved more into system solutions. So in the process, I led engineering teams, and then I led a business unit, and then we ended up creating a focused group for aerospace and defense. And my role in that really has been to bring all of the technologies within ADI, drive the kind of technologies we develop to really solve the bigger problems that the DoD is working towards, instead of just providing components. And so the kind of things we're doing, the kind of projects I'm involved in, a lot of phased array work, and phased arrays are sort of the next frontier in using resources, whether, and it's a way to direct energy or be able to communicate almost point to point, or be able to pinpoint a radar or to pinpoint different things. It's a lot of activity at Analog Devices across the entire development space for phased arrays. So that's a big area. And that applies to radar, to communication systems. We're also, because of our core technology in RF and high-speed data converters, we're also deeply involved in developing digitizers and systems for electronic warfare and other critical sort of spectral dominance kind of technologies. And those are all I'm involved in. And as we develop these bigger solutions, we're finding, and that's one of my big activities now, is we need to start incorporating, or we are incorporating, more digital processing, working outside of the traditional space that analog devices used to work in the components.
Mm-hmm. Mm-hmm.
And that starts getting you into AI and ML, which is of course ubiquitous now. Everybody talks about it, but it's a big
Mm-hmm.
part. Encryption, another way, protecting data, protecting
Mm-hmm.
solutions, um, using light instead of electrical signals, known as photonics, and then probably
Mm-hmm.
something we'll talk about later, which is advanced packaging and semiconductors, because that's still part of the core. So now, as opposed to just worrying about the semiconductors, now we worry about all these other aspects that make a full solution.
Okay, yeah. So the kind of that what makes that whole package and makes the technology work.
Exactly.
Okay,
Exactly.
great. So how do you think all those technologies that you talked about, and you touched on this a little bit, but how could they benefit the DoD as a whole?
Yeah, I mean, what we see is the threats facing the DoD and the services are actually being enabled by the very technologies that we're talking about here. So that those technologies are not captive to us. So
Hmm.
the important thing is bring those to bear in the most effective way to deal with the challenges. So um, it's become more and more important to accelerate and actually be ahead of what's coming. And so we know there are commercial developments that can be misused and be used against us. So um, we need to kind of challenge those, and we need companies like ADI who do this on a commercial scale and have that expertise to develop these chips and develop these solutions quickly, as opposed to it being a subset of what a bigger company might do. To us, that's core.
Right. Yeah, absolutely. Absolutely. So today I'd love to kind of have a bigger conversation about onshoring and re-onshoring technologies in the US, which I know is a deep and far-reaching issue and effort. So can you first walk us through the US's like current capabilities in term of microelectronics technology production?
Yeah, no, I'm happy to. I would like to start by saying, the actually a lot of these technologies were developed and had a big the
Hmm.
US had a big influence in the beginnings of these technologies. What I see today, and I have to admit the beginnings of the talk of the Chip Act during COVID, I have to say I was a bit skeptical. How are we going to turn this train? But I'm very
Sure.
I'm very
Yeah.
pleased, by the actions and the commitments being made. And it's not an overnight project,
Yeah.
and there's a whole need for prioritization of what gets done first, what has to be
Hmm.
onshored most critically. There's also the idea of friend shoring, so not everything has to be brought on
Hmm.
US soil, but we have a lot of
Hmm.
allies, so that's an important piece of the network. And finally, I would also say that, onshoring is nice, but the onshoring has to also have, and that's where ADI plays a role, also has to be commercially viable because it needs
Sure.
to be sustained. The investment to get things started, build facilities, get equipment is one thing, but maintaining the flywheel and getting that leverage year upon year to keep advancing the state of the art does mean that it has to be viable commercially, on a day by day, year by year basis.
Right, absolutely. I heard you use the term friend shoring. Is that just onshoring through our allies? I've never heard that
Yeah,
term before.
exactly. Yeah, exactly, exactly. We have allies, long-term allies, trustworthy allies, and they also have capabilities, and sometimes it makes more sense, either
Hmm.
geographically or for other reasons, to not have it all in one place.
Yeah.
One of the challenges we'll find is if there are, if each separate entity or region has its own ecosystem, there won't be enough scale, and so costs will go
Mm.
up. So that'll be a natural consequence, and again, to be viable commercially, we have to maintain the economics of the industry, or it will stall.
Yeah, yeah, absolutely. Very interesting. So I think you mentioned this briefly. Can you walk us through what SOC, a system on a chip, is and how it's made?
Sure. SOC actually was driven by this incredible progress in the semiconductor technology. An SOC, system on a chip, is exactly what it means. It means there's a lot
Mm.
of functionality all brought under one single chip.
Okay.
And by putting everything in one, you solve a lot of the connection between different functions. Customers can take the big chip and not worry about what each little piece is doing. And if architected properly, allows you to go build your solution much more quickly, um, and not have to solve all the minutia problems that you used to have to solve by combining a bunch of different pieces. And it's very efficient, but it does have downsides. It is very expensive to develop these chips. It takes an army of people many years, and if anything changes, you have to redo it. So there's an update cost, and so this only works when you have really high volumes. If you're making chips for cell phones, or you're making chips for Game Boys, or you're doing things for cars that have that volume, you can do it. But it doesn't work so well for the DoD, where the applications are more fragmented. They have very special needs. Some of the needs are classified, so there are a lot of challenges to using the SOC model for the DoD.
Interesting. Yeah. So what made this an effective solution for so long?
Yeah, for a lot of the markets, especially the high volume commercial markets, it's the fact that you can make things smaller. They actually become cheaper per function, and you can just pack a lot more stuff in for those markets. Um, and it's been very, very successful. But it's not the panacea for everything. And there've always been a need for separate uh, sort of customized build things that have to be done. But there are changes now that create something in between an SOC and the old sort of discrete put together pieces on a board.
Okay. Yeah. So it sounds like we're moving away from the SOC structure and towards advanced packaging. So what makes advanced packaging different and a better solution for the DoD systems?
Right. So the advanced packaging is kind of trying to bring the best of both worlds. It's creating something that might look like an SOC from the outside. In other words, lots of functionality. The problems between different pieces are solved, but it's still separate different pieces, but they are able to be put very close together. One name used for them instead of chips are chiplets, sort of
Oh.
a tiny chip. It
Hmm.
really is the fundamental semiconductor that you're putting side by side with other like-minded chiplets, and together they perform something like an SOC. The difference, though, is if something needs to be changed in this chiplet based on advanced packaging, you might just have to change one chiplet and not
Okay.
do the whole thing again. If you have to make a variant, it may not be the amount of work needed, and the time can be significantly reduced. You can have
Right.
variants instead of trying to solve everything in one big, huge chip.
So less wasted time and less wasted materials, it sounds like.
Yeah, there is a yeah, it's there's another piece you mentioned, wasted material is there's a concept in the semiconductor industry called yield, and it has to do with when you make 1,000, how many actually come out functional and how
Mm.
many you have to throw out. It
Yeah.
turns out that the bigger something is, the lower the yield. So if you can make
Mm.
the mathematics works out that if you can make a function out of a bunch of smaller things, you're actually ahead than if you try to make it out of one big thing.
Mm.
So that is to the point. It becomes potentially lower waste,
Yeah.
but more you can update your systems. You can put the new version out without having to do a whole SOC again. You can maybe just update one or two of the chiplets in a
Right.
multi-chiplet solution, but that's all enabled by some advanced packaging that basically is almost like another level of integration, not quite as an SOC, but not as coarse as what we do
Mm.
today on what they call a PC board, which is the typical board where you have all the components individually put down.
Yeah. Okay. Fascinating. So it's my understanding that advanced packaging production capabilities is another thing that needs to be onshored or
Yeah.
re-onshored. Can you speak to why this is such a critical need for US defense right now?
Yeah, absolutely. So some of these capabilities, in fact, I would say packaging was even more dominated by overseas operations than even the semiconductor, mostly because it's historically been a lower tech kind of need, not
Okay.
requiring very expensive fabs or equipment.
Mm.
Um, but now this idea of putting these chiplets together with advanced packaging is calling for some more sophisticated capabilities, and these do exist already overseas. But in this case of concern about supply chain and so on, we do need the ability to at least prototype these advanced
Hmm.
packagings and push some of the packaging capabilities. And that packaging starts getting into a lot of concepts like, how do I get the heat out of my solution? How mechanically the mechanical integrity of the solution. When
Hmm.
I start putting all these things together, and there's different materials, they have different properties, and there's a kind of a menagerie of different physics that has to be applied to make sure these solutions are robust. They survive the environment, and they allow you to put together what you need without upsetting the how signals go from one chiplet to another chiplet.
Okay, that makes sense. So now I'd kind of like to mention Microelectronics Commons, which is a program under the Smarts OTA, and you mentioned earlier the Chips and Science Act. So I'd be curious to hear how you see the development of this national infrastructure contributing to the DoD effort to re-onshore these technologies.
Yeah, the ME Commons brought, it brought this piece that's been missing in many ways from our ecosystem, because we had a lot of programs developing fundamental technology, taking
Hmm.
big risks, mostly intended to fail, so you could find the
Hmm.
real strong ones. On the other end, you had the manufacturing, even companies like Analog Devices working on the commercial side, making products. What was missing is something in the middle that bridges. It's called the Valley of Death, that would bridge the that fundamental research that's very strong and the commercialization, which is also very strong. So MA Commons is bringing this combination, this organic ecosystem of universities, small
Hmm.
businesses, the defense primes, and non-traditional suppliers like ADI, government labs, et cetera, to sort of address this valley of death and accelerate and facilitate the progress from fundamental technology to into the final deployed systems, because it's just taking too long, and probably many good ideas get missed because we just don't have the right players at the right time taking the baton at the right point.
Hmm. Yeah.
um, because it's so easy to drop that, as gosh, it's too far to revenue. Commercial companies don't want to touch something that seems 10 years out, but it turns out, that it's not that far out if we can put our heads together. So I think it's a new way to bring the full strength of the semiconductor industry all the way from pure R&D to commercialization.
Yeah, yeah. It sounds like there's like a lot of skill getting lost in that gap, in that valley of death, but Commons is it's bridging that gap with the production capabilities.
Yeah,
Um,
and it's connecting partners and that may
yeah,
not normally connect with each other.
yeah,
So I think that's important, and finding common missions there and seeing value in engaging early. For us who are more on the commercialization side, it's important for us to be aware and engaged earlier, to be aware of the problems that are trying to be solved, and so that we can be prepared for when it comes in.
yeah, yeah. And that's a good transition. I know Analog is involved with Microelectronics Commons, and you're a member of the Northeast Microelectronics Coalition Hub, which is one of the 8 regional hubs for Commons. So can you walk us through your involvement with this hub and what technical capabilities you hope to contribute to the effort?
Absolutely. So we participated here in, as you mentioned, the New England hub, and we were part of the sort of first trench of exemplary proposals. So these were the dream up things as a center and submit them for together with all the other centers to try
Hmm.
to find scope and different activities that would
Hmm.
benefit the DoD. So we were part
Great.
of that.
Okay.
And it, of course, we worked with this ecosystem we just talked about in the New England area. And some of that project's details ended up on the various official call for proposals. So it's interesting to see how the system's working. And again, this is the first year we've done it, so I think
Hmm.
there'll be modifications and fine tuning of the process to make sure, to understand, how far the dollars go, what kind of scope. This is
Yeah.
not basic R&D. It's somewhere in the middle. So I think we're finding our footing on what how we monitor the value that's created through this
Yeah.
process. But
Yeah.
it's definitely something we needed. And this format is interesting because I think we needed a shakeup in who
Mm.
participates in these kind of funded programs and how we network.
Yeah, yeah, that's great to hear. And it's just the start of Commons too. So like you said, it'll be fascinating to see where it goes and how things change.
Absolutely.
Um, yeah. So Analog is a non-traditional contractor in the commercial sector, like you said. So how has being part of an OTA benefited you?
Yeah, so Analog Devices historically has always invested its own money in developing technologies. That's how commercial companies work. So
Hmm.
the OTA allows us to, and by the way, in so doing, the accountability is really to our bottom line. So the OTAs allow companies like ADI uh, to participate as non-traditional performers,
Hmm.
and bring their own weight and not and follow a different set of accounting guidelines. So it just makes it easier for us to bring our commercial scale, and to engage with primes and with others on some of these programs. Um, I would also say that we are also capable of participating as traditional suppliers,
Right.
in OTAs and in
Hmm.
full programs. We do have that capability,
Okay.
but it tends to be much more efficient in OTAs because then we can really leverage our commercial scale.
Yeah, absolutely. Really fascinating. Well, thank you so much for your insight and for joining today. I know I learned a bunch from you. And yeah, I just appreciate your time.
Yep. Thanks for the opportunity.